Example number 2 is a related rates problem. Let me read it to you guys out loud and then we'll go from there. It says a hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. At the moment the rangefinder's elevation is pi over 4, the angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at that minute, or at that point in time? So here's what we have. Let's draw the picture. I've got a balloon, and it's rising, okay? And the height that it's rising, and I apologize, my smart board is not so smart, right in the middle for some reason. It's on level ground, and they are 500 feet away, and we have a rangefinder here. And notice that that makes a right triangle, and we're talking about theta. And so, let me read it one more time. It says, the hot air balloon is rising straight up from a field. There's a rangefinder 500 feet away from the liftoff point. At the moment the rangefinder's elevation is pi over 4, the angle is increasing at a rate of 0.14 radians per minute. How fast is the balloon rising? Now they told us something. They said that d theta over dt was equal to 0.14 radians per 1 minute. And they want us to know how fast was it rising, which is, they want to know dh dt. So then what we need to do here is we need to try to find the relationship between theta, h, and the 500 feet. Now, you could probably use any one of your trig functions if you want to, but just remember that this is the opposite side, and this is the adjacent side, and this is the hypotenuse. So we're given, or we're looking for the opposite, we're given the adjacent, and we're technically actually given theta, which is pi over 4. So which trig function relates opposite and adjacent? Soka toa.
Oh,
Tangent, right? So what I need to do is I just need to write down the relationship. Tangent of theta is equal to the opposite over the adjacent. Or tangent of theta is equal to, in this case, h over 500. Now the reason I did it that way is, here's another scenario, just like that other example that we did. We have the variable a, which is the adjacent, but we're given a number or a value that isn't going to change. So I have 500. So really I've got 500 tangent of theta is equal to h. I'm given d theta dt. I have to find dh dt. What do I do to this equation? Differentiate with respect to t. So if I take this whole thing and differentiate with respect to t, I'll get my dt dh. Well, the 500 remains the same. We just toss it to the front. What's the derivative of tangent? Secant squared. So I'm going to have secant squared of theta, right? D theta and dt. We're not taking the derivative with respect to theta, we're taking the derivative with respect to t. All right, well that's equal to, what's the derivative of h? 1 dh dt. Guess what? I know that theta at this instant in time is pi over 4. I also happen to know that d theta dt, that was weird, just kind of freaked out on me there. dt is equal to 0.14 radians per minute, right? So I could just plug in a bunch of numbers and I should get the answer. Does that make sense? So let's do that. 500 times secant squared of pi over 4 times 0.14 radians per minute is equal to my change in height with respect to time. Does that make sense? Now, I could use my calculator. The calculator doesn't have a secant squared. Well, I mean, we could do like the, what was secant? What's secant? We only have sine, cosine, and tangent. How could I represent secant in the calculator?
1.
1 over cosine, right? Could I do 1 over cosine squared and get the same answer? Yeah, but you know what, pi over 4, that's pretty easy to do, right? So, if I have my 45-45 or pi over 4 triangle, I've got 1 root 2. And so, since secant is the reciprocal of cosine, let's figure out what cosine is. Well, cosine of theta is equal to the adjacent over the hypotenuse, right? Which is 1 over root 2 or root 2 over 2, right? Secant is the reciprocal of that. So if I say secant of theta, I'm really saying 2 over root 2, right? Or I could make it a little easier on myself since we're reciprocating that anyways. This is technically 1 over root 2. What's the reciprocal of that? Root 2, right? So now how do I write this in here? Well, I'm just going to say 500 root 2, but remember it's squared times the 0.14 radians over 1 minute is equal to dH dt. Let's plug that in the calculator and see what we get. Well, we have 500, well I already kind of know, but 500 times root 2 squared, which is really just 2, times 0.14. It's really 1,000, so it'd be like 14,000, and you move the 2 decimals. What's that? 140? Yeah. So what is it? It's 140 radians per minute, right? Somewhere to go, we got to cancel out the radians. Oh, from the 500 feet. Where did the radians cancel out from, though?
Is it pi over 4?
So yeah, somewhere it cancels out. But yeah, it's 140 feet. Sorry about the sloppy handwriting, but the smart word isn't being very smart today. Okay? And that's 140 feet per minute.